We are trying to shift the cognitive load, as much of it as possible, from human to the machine when it comes to investigating security alerts, coming to some sort of a verdict, deciding whether something needs to be contained, remediated, eradicated, etc.
Thanks for joining for this episode of the TechSpective Podcast. I have with me my friend Leonid Belkind from Torq. So welcome back.
Thank you so much. It's a pleasure to be back, and hopefully with interesting stuff to share.
Well, I think we do have some interesting stuff to share. So the reason I wanted to have you on is to talk about this the SOC brain. I mean, we've talked a lot about autonomous SOC and stuff, and Torq has done a lot of interesting things in that arena. But now we're talking about taking the AI SOC to a level that isn't just remembering, but also learning. So walk me through the SOC brain.
Absolutely. And by the way, I have to tell you, first time someone in the marketing coined this term, I was, I'm a technologist. You know me. Somebody gives me a big marketing term, I'm like very skeptical. But honestly, the more I thought about it, the more I felt that what we're actually emulating is a lot of aspects of how human brain of a security analyst thinks. We are emulating it with technology. Now, first and foremost, what is the goal? What are we even trying to achieve here, and why is this brain needed? We are trying to shift the cognitive load, as much of it as possible, from human to the machine when it comes to investigating security alerts, coming to some sort of a verdict, deciding whether something needs to be contained, remediated, eradicated, etc. Why are we doing it? I believe everyone listening to the podcast knows how overloaded security analysts are, how, with years, attack surface of any digital enterprise just keeps on growing. As a result, more and more variety of various alerts of what could possibly signal that something bad is going on lands on the table of analysts. So far, nothing new. Now, if our goal is to have people do less and hopefully more quality work and machines do more, the question is, how can we confidently shift this thing? And this is honestly where this whole notion of it cannot just be the equivalent of working hands, but we also need to take some of the things that brain of a human analyst does. That's where it comes to place. So far, setting the frame. Okay, now, early on in development of artificial intelligence, the industry has come up with the notions of retrieval-augmented generation, vector databases, etc., that allow us to pull some relevant precedents or some relevant data points, add it to the context of the question we are framing for artificial intelligence, and have this influence the outcome of this thing, right? Not for nothing, it is called in-context learning, right? Because you take some data, put it in the context, just as if I were to ask you, Tony, so what do you think about this security issue? And you're looking at it, or I would say, what do you think about this security issue? And so that these are the users involved, and these are their roles, and this is the history of their actions, and this is a history of similar security issues in my environment, etc. Naturally, you'd be able to come up with a way more intelligent answer in the latter case than in the former. In context learning.
Right.
What's wrong with that? Honestly, nothing is wrong with that, and this is one of the techniques we use. But there are costs involved. In context learning means what? That all the data you've collected is being sent out to some sort of large language model. Most capable language models today, if these are frontier services, the likes of Anthropic models, OpenAI models, Google models, these services are being priced by the amount of information you send there. So suddenly it's a very strange economical thing where you go ahead and say, hey, I wanted to provide more context to make a better decision, but then it costs more. That's not the only problem with it. There have been a lot of studies that actually show that while models are vastly improving, The more information you give it, the more sort of like it opens the door for inconsistencies. And I'm not even talking about hallucinations. I'm truly talking about inconsistency, variance in extracting the information, inference, etc. And this is honestly what we saw when we first started deploying previous generations of our AI SOC solutions. And this is what prompted us to go ahead and start investing in a research of learning rather than remembering. Now, let's talk about what this learning actually means. In his award-winning book about fast thinking and slow thinking, Daniel Kahneman actually defined two distinct systems in how human brain, helps make decisions. There
Mhm.
is system one that is, your reflex, your gut feelings, your muscle memory in some case. Very cheap, very fast, honestly right most of the time, but it is instinctive, right? If,
Right,
if
right.
if if you get an instinct, I don't know, a hot beverage is being spilled, your instinct is to move away. I won't be able to go ahead and ask you, Tony, could you please point me to the exact moment in your personal life experience where you learned that hot beverages being spilled means something painful? You probably won't be able to point me at that. However, this is the instinct you've been trained. Unlike system two, that is retrieval of precedent, cognitive analysis of, how relevant is this precedent to the decision I need to make right now? Maybe somewhat relevant, maybe completely relevant, maybe let's discard it irrelevant. So honestly, learning in order to shift the cognitive load, make distinctions, follows this thing. Now to the technology. So if we want to emulate these two ways of thinking, what do we need? Honestly, for the muscle memory, the right emulating component is to train a model. Why is it to train a model? Because then you get the fast, you get the relatively cheap, and you get this thing where the amount of information doesn't matter. The way we implemented this, let's take us to a very, very concrete example, and I may even share some visualization here to explain it. So our reflex, that's literally how we call this mechanism, because that's
Mhm.
what it is built to resemble, is done the following way. First of all, the job we'd like to do here, a security signal comes in. We would like to go ahead and provide, in addition to analysis provided by an opinionated, trained solution managed by our security operations, we would like to develop a muscle memory, a gut feeling that is unique for an organization. How does that work? We take, first and foremost, uh, reflexless signals that constitute to a good, best industry practices investigation, and then they undergo specific investigation in your organization by your dedicated automations, bespoke agents, sometimes even analysts. And then one of the following three things, and three things only happens. One, maybe after a deep investigation, you confirm the result and you say, oh, wonderful. The system told me it was a true positive malicious thing. What do you know? Turns out it is. Good. We call that a bronze data point, something that signifies confirmation. Slightly worse for this particular signal, but way better for learning. What happens if, after a deeper investigation, you reach a conclusion that the initial verdict was incorrect? No, this is not a true positive. This is actually a false positive signal, nothing to write home about. Perfect. That is actually a much bigger learning opportunity. This learning opportunity is called a silver data point. Best, and the best thing we could all hope for is not only that somebody tells you that, yeah, this verdict is incorrect, but they also explain, bring evidence, point at existing evidence, showing why. This is a gold data point. Now, how do we turn these silver, bronze, and gold data points into learning? Learning in this context begins with us training, post training, if we have to be very, very exact, an encoder model on the specific sources of an alerts, types of actions, tiers of analysis, etc., that the organization has. How do we do that? We build a document, JSON or whatever format, that has all the details of alerts in it. Where did it come from? Enrichment of all entities involved, users' roles, devices status, all actions taken, all comments made, all evidence attached. Encoder model, unlike models that many of us work with on a daily basis, it does not provide its output in a natural language. That's the job for decoder models. Encoder models creates a feature vector, like a comma delimited list of a lot of floating point numbers. Exactly how many actually depends on the model architecture and and the amount of parameters. Could be 128, could be 256, could be more. The meaning of that vector for every given document is sort of like the understanding that the model gives. Why do we need to train a model specific for each and every organization and each and every environment? Because honestly, yeah, sources of alerts, their sort of like combination, types of actions that people are taking, operational practices are truly different. Now, what does it help us? So we get these alerts, we translate them into really big vectors. Now we can actually train a classifier neural network to go ahead and say, okay, if this group, and I'll draw dots in a two-dimensional space, naturally it's slightly more complicated in a 256 dimensional, but never mind.
Okay.
So let's say this group represents all alerts that were deemed as true positive malicious by our analysts. Okay. Let's say this other group in here in the corner, that's the false positive alerts. And somewhere in here, there are benign alerts. Now, a next alert, I'll write it in green, and this diagram comes in. Naturally, it will undergo analysis, it will come up with a verdict. But now having this trained encoder and a classifier neural network allows us to position this green dot, say, here, and see that, how interesting. It looks way closer by its different properties to the, true positive malicious than to false positives or benigns. So this is the equivalent of this gut feeling, knee-jerk reaction, and so on. Now, why do we need it? Honestly, it affects how trustworthy, consistent the verdicts we see as being, and serves as a risk score to our ability to go ahead and do something about it. Think of your private life, Tony. Haven't you ever faced a decision where, you know what, both your head and your heart told me I should go for it, and how happy you were to go ahead and do it, versus the head tells me this, but no, the heart tells me I need to do the other way. Make sense?
Yep.
Similar here. Now that is an equivalent of a heart, and that is one type of learning. Now let's talk about the head learning, because that one also exists. Same idea. Alerts go in. Again, with or without the gut feeling, they get assigned a certain initial verdict. They undergo, again, agentic, deterministic, manual work, get resolved with a verdict. Now, smart people learn by building patterns, building associations. And these patterns and associations are specific to the domain they're learning. Smart and experienced security analysts, right? They think in the dimensions of an attack. Potentially MITRE attack tactics and techniques involved, potentially certain observables, etc. So we emulate that way of thinking by creating a very unique, specific to the type of a attack being involved here, index. Why is that important? It is important because, when you learn something, the efficiency of learning is measured by, when the time comes, how quickly can you pull this from your memory. So your ability to go ahead and say, okay, I'm now dealing with a green alert. The previous one was red. How quickly can I pull the relevant precedents? How quickly can I recall them, right? And then figure out, oh, okay, how relevant are they? Are they exactly the same? Are they the same but, and so on, and create this head. So what this actually drives is both mechanisms, just like in real life, right? The head and the heart work in tandem. And for every alert being evaluated by the system, in addition to what a disconnected from your environment thing thinks it is, you get a reflex and you get the recall. And now let's talk, because if all three tell you the same thing, your confidence to go ahead and deploy containment, eradication, etc., fully autonomously should be very high. If they
Okay.
disagree, this is where this reconciliation comes. So hopefully, I know it was a short question and a very long answer, but you see where I'm starting to distinguish between just having a memory and actually learning. Does that make sense?
Yes.
Now, imagine, and again, it's not an imaginary thing, what if we could learn, not from experiences that you and I are having right now, but what if we could do proper learning based on something that happened before us, right? And we humans definitely try to do this thing, right? You don't have to experience every single bad thing yourself in order to learn that they're bad and not do it. Honestly, with these mechanisms in place, a similar paradigm can be emulated because usually when we deal with security operations, we come into an organization had some sort of a system of record, that they have some sort of a history, and if we can go ahead pool both the alerts and the history of what was done about it in terms of investigation, in terms of containment, what turned out being the root cause, and so on and so forth, import it in a normalized way, generate both the recollection memories as well as the reflexes based on that, then suddenly day zero, when this thing comes into functioning in your environment, it is actually already learned with both the right knee-jerk reactions and instincts, as well as enough of a cognitive recollection to go ahead and do things. And this, honestly, is not very possible with humans, right? You bring in a human that they cannot get someone else's brain dump that were here before them, but this system truly can. And that's what our brain is all about, honestly. Now you see why, at some point I looked at the marketing superlative and said, you know what? Surprisingly, these people are not entirely wrong, or maybe even very right.
Yeah. Well, I agree, and I think that it's interesting to use those three terms, and and to compare it back to like you said with the I forget the exact name of the book. I actually read it, but the fast thinking with the
Slow thinking, fast thinking, I think is
right.
the name of the book. Yeah.
Um, and it is interesting because like you said, there are things that just are just reflexive. I mean, even some things that are learned become reflexive. Like
Absolutely.
I don't have to think about 2 plus 2. Like
No, it's definitely four.
that's an immediate. It pops into my head. I don't have to figure out how that works. Um, and but when you get to the retrospect part of this equation, there's the okay. Well, I've got my instinctive reflexive reactions.
Mm-hmm.
And also I would say that there's the distinction here between reaction and response. Whereas like
Correct.
so I've got my instinctive reactions. Now I might have my more reasoned, considered response to something that I have time to think about. But then where retrospect I think is very important is there has to be some sort of a feedback loop that lets you retrain the reflex because maybe your reflex is wrong.
Might happen sometime. This is honestly one of the questions that people ask us the most. Go ahead and say, okay, so you're learning from what my analyst did previously, but what if what they did is wrong? And the truth is, okay, what if what we're learning in life is wrong, right? Haven't you ever? I think that at the end of the day, it's the survivor's bias to an extent shows that if we lived long enough to see this day, while we definitely made our share of mistakes, in terms of what happened more often, we were probably more often right than wrong. Honestly, if it was the other way around, we would not have the pleasure of having this conversation because we'd be all dead because of our bad decisions. Now, honestly, similarly with the SOC, does every history, every point that we inspect in retrospect, uh, does it constitute a 100% correct decision? We never assume that. But when doing this learning on a multiple set of dimensions, this is exactly what does the calibration, right? Because again, with the reflex learning, you're saying let's not jump very high because maybe we'll land and it will hurt, right? Does that not mean that once upon a time at a PT class in your high school, you didn't manage to actually execute an awesome jump? Each and every one of us had it. But it doesn't really, to an extent, take away from your reflex, right? A hot coffee being spilled. You know what? I had a couple of lucky strikes. It spilled, but not on me. Nothing bad happened, neither to me nor to my clothes. Did that teach me to go ahead and say, oh, yeah, the coffee cup is going over, let's do nothing about it? Not really. Same here. There is, when doing this learning, there is a corrective bias. For example, in our case, um, making a mistake and looking at a malicious signal and saying, that's okay, is way worse than looking at a benign signal and saying, it still looks suspicious. Let's invest more resources in investigating. And in order to have our learning follow that logic, we use something called the weighted cross entropy. When we are training that classifier neural network, misclassifying in different groups carries different weighted penalties. Misclassifying something bad and putting the decider in a harm's way is penalized way more than misclassifying something good and wasting someone's time. And that honestly also resembles how we humans learn, right? It's the risk averseness that we have, right? What is the worst possible outcome? How afraid I am of it versus what's the damage if I go ahead and try it? What's the worst that could happen? Same principle applied, honestly.
Okay. One of the so I'm gonna go off into the weeds here a little bit. One of the things that I've been kind of focused on and starting to not be worried about, but just be aware of and say, okay, this is something we should consider. Is the like, okay, well, as we adopt these tools, as AI becomes mainstream, as we're relying on AI, um, well, setting aside, what happens with the uh, sort of intellectual capital of knowing how it works. Like if it's like the thing that has come out about how people don't remember phone numbers anymore, or they don't really know how to read a map anymore because you don't need to.
Or multiply two big numbers without a calculator, for example.
Right, and because you don't need to, it's like, okay, that's true until it's not. Like, at some point you might need to read a map, or you might need to learn how to, you might need to do some actual math calculations, and so you still need to have those abilities. But more importantly, and the thing that I'm focused on more is the not so much, okay, well, what if you needed to do that? It's, will you know that you need to do that? Like if you're just relying on the AI tools, will you know when they're wrong?
So first of all, I think it's an actual dilemma that many in the industry are currently dealing with. And honestly, if I think about, let's say, all of my current and former colleagues, the dilemma, if you think of it, Tony, is not unique to, let's say, security operations. You know how everyone talking about coding agents, Claude codes, cursors, and so on, is now talking how the new age programmers don't really write code, right? And they just rely on agents to generate tons of code for them. I still believe that in this reality, I mean, I know that is true in my organization, a good developer still strives to understand how things work under the hood. You may have only, let's say, a driving license to drive an automatic or transmission cars, but do you fundamentally understand how is it that the pistons in the motor go at the same frequency and your wheels turn faster and faster? How does this transmission thing work, right? The motor doesn't go just constantly faster. There is a certain amount of rotations per minute, and somehow it changes. So, right, if you are curious, if you, despite having a high level interface of doing something, you strive to understand what's actually happening under the hood, I think when the time comes, you'll be able to remember the phone number or multiply two numbers, right? I think it is not about the tools that you have. It is truly about you, how curious you are in nature, and how much responsibility do you take upon, I really know what I'm doing, right? And it's perfectly fine. There will be two types of people. There will be people that will suffice with, I don't know what I'm doing. I'm just pushing the red button and it does what the red button does. And maybe there will be roles where this is sufficient. And there will
Yeah.
be people that will know what exactly happens when the right button closes this electric circuit. And it's perfectly fine, honestly.
Well, and I'm also conscious of the fact that while something might feel like a problem, like, oh, maybe it's a problem that people don't know how to read a paper map anymore, but it's like, well, is it a problem? Like like in the examples like you were just talking about, like most people know how to drive a car.
Hmm.
They can't tell you how an internal combustion engine works. It's like they don't need to. It's like they can just use the car.
Correct.
Like everyone, like I use a microwave pretty much every day. Like I don't really know how it works. I don't really care how it works. Well, all that matters is that it
Knowledge. Yeah,
works. Um,
correct. Now,
but at some
there's a
point,
question,
at some
right?
point when the car breaks, though, I do need to have an expert that I can go to that does know how that works.
Perfect. Same with any electrical appliance that you have in your house. Spot on. So the question is, what is your role in this particular equation? Are you purely a consumer? In which case, you know what? I have very rudimentary understanding of indeed microwave and how it works. I heat up my food twice a day at least, every day in my life. Now, that's where I'm a consumer. On the other hand, we are a vendor of security operations solutions, AI-driven ones, etc. There, I am that guy you take your car to, and
Right.
there it is my job to understand how it works under the hood, and 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 it's perfectly fine, right? I don't think that people should feel, oh my God, I'm not able to use an electrical appliance that I do not have an intrinsic knowledge of the workings of. That would actually very much limit your ability to benefit from the modern standard of living. Same here.
Okay. Well, going back to the beginning, like I think this is cool what you're doing, and I think when you started off talking about retrieval augmented
Generation.
generation or whatever, and and I think it's an interesting distinction to say that there are things that AI does now, that are designed to seem like learning. Like there are things that like make it seem like it's more intelligent than it is, that are really just kind of like sleight of hand parlor tricks.
Oh yeah.
And I like that, walking through reflex and recall and retrospect or whatever is, kind of illustrating like, okay, well, there is a a better, a more in-depth way to do this that isn't just kind of putting a facade of learning on AI.
Absolutely. And honestly, modern AI, Tony, and you experienced it probably the same way I did. It has this magical appearance, right? Never ever before the invention of it, you could type an idea that high level into a computer and get an outcome that is so close to what you actually typed, whether it is in generating a document, writing some software, generating an image, generating music, etc., etc. It is, and I'm saying that as a computer scientist, amazing.
Right.
Honestly, like all inspiring. But at the end of the day, then when you come to translate it to a much more narrow task. That's what we're doing with security operations, analyzing security signals, et cetera, et cetera. You cannot remain at that level of amazement and just saying, "Oh my God, I just threw this problem at an LLM and it gave me a response. So great." It takes away all the accountability. Why do you claim that this alert is malicious and that one you don't need to do anything about? Uh, how well did you invest in making this claim? Because at the end of the day, we're accountable here. We're accountable
Right.
to safety of digital information, human healthcare information, financial information, critical infrastructure, etc. Right? When we say shifting the cognitive load, shifting the responsibility, that one does not work. If
Right.
your healthcare provider, God forbid, loses your data, you come and demands them to be accountable, and they say, "Well, Tony, we just trusted the AI model with it." I don't think
Right. Like
you're going to.
if I ask AI, if I ask an AI, to find me the best pizza place in a 10-mile radius, and it gets it wrong, I get a mediocre pizza. But if
Nothing bad happens.
but if the sock gets it wrong,
Oh yeah,
systems go down, networks go offline, and bad things happen. So yeah, you have to keep those things in mind. So I know we're basically at time, but I wanted to say, so keeping all of that in mind though,
Mhm.
if we fast forward a year, we fast forward 2 years, which seems like an insane amount of time these days, because I
Absolutely.
feel like everything changes in like 3 months now. Um, what's the proof point? Like, what's the metric for saying, for differentiating this learning versus the facade of learning?
So honestly, indeed, in the pace of current technological development, it is very, very difficult to make predictions. The famous Yogi Berra affiliated statement that it's hard to make predictions, especially about the future. Well, if
Yeah.
Yogi Berra was alive today, I think this statement would have been, way more right than it was during his time. But still, I really think that's the amount of cognitive load that you shifted. Because honestly, if all you do is this facade of learning, then at some point, quite soon in time, you'll start getting tasks back on your table, right? The true measurement of how successful this technology is will be when we'll see that the analysts that we have truly start investing time in more proactive, more deep analysis rather than wasting. Of course, it's not wasting, it's spending,
Right.
but spending unwisely and inefficiently their time. At the end of the day, right, the job is not to eliminate humans, but to focus humans on where they matter and have the machines truly do things that humans maybe could have done, but less efficiently, less consistently, etc. That thing, if we manage to shift it, and we are starting to hear that from the organizations that actually are adopting this approach, that they start seeing this shift, that they're humans that are not going anywhere, nobody's downsizing them and so on, but suddenly they're doing more impactful things. That is the shift. That's what happens. That's how security posture of all of our digital world components together gets improved, and we get to trust our banks, our insurance companies, our airlines, our healthcare providers, and whatnot more, knowing that they're not chasing their tails on any given day, but are actually being proactive and investing in continuous improvement.
Yeah.
Not
I mean,
a not a simple goal.
no, but in the end, I think there's on some level, we eventually want these AI tools to be the microwave. Like I want, like okay, I could go start a fire, and I could heat my food up the old-fashioned way. Um, but uh, that takes time and stuff. So
Yeah.
like by using the
If you have to
microwave, I
do
can
it
do
three
this in 30
times a day,
seconds, and I don't have to
three
think
times
about
a
it.
day for every major meal, I don't think you'll be able to accomplish enough during the rest of the day, honestly. That's
No.
the thing, right? And sometimes, you didn't touch an important aspect, that sometimes there is this maybe irrational concern. Now, how can I make the AI decide for myself? But honestly, people have grown up trusting technology. You go up on an airplane, there's a crazy amount of technology there keeping you alive, right? During this flight. That's what happens. And I truly do not see how applying AI technology here is is different from that level of trust. You trust something with your life, you trust something that is equally advanced as a technology with proof points, with observability, with your mission critical decisions. You absolutely do. It's not like the humans that used to do them before were perfect,
Right.
blameless, never making a wrong distinction ever in their entire lives, right? That does not happen.
All right. Well, thank you. Thank you for taking the time.
My pleasure as always. We'll be looking forward for more opportunities to connect.
All right. I appreciate it.
Have a great day.
You
Thank
too.
you.